Ladies and gentlemen, the following speaker needs no introduction. In fact, if it wasn't for him and his fellow compatriot, Vince Cerf, maybe we wouldn't even be here today, having this Congress. Along with Dr. Cerf, Bob Kahn invented the Transmission Control Protocol and the Internet Protocol IP, the fundamental communication protocol at the heart of the Internet. After receiving his bachelor's degree in electrical engineering from City College of New York, Bob earned his master's and PhD from Princeton University. He began his career at AT&T Bell Laboratories and became an assistant professor at MIT after finishing graduate school. He took leave of absence from MIT to work for Bolt, Vernac, and Newman, where he designed and helped develop the interface message processor, which was the packet switch node which created the original 4-node ARPANET in the late 1960s, which grew substantially during the next 2 decades and was finally decommissioned in 1990. Bob Kahn was the principal architect of the packet radio network, a forerunner of today's code division multiple access systems. He also helped to create the packet satellite network based on Intelsat 4 to link US researchers and their counterparts in Europe. During this period, in the early 70s, he came up with an initial architectural idea which later became the Internet in order to enable those 3 packet networks and computers connected to them to develop the TCP, the Transmission Control Protocol, which was intended as a replacement for the earlier network protocol used in the ARPANET. Dr. Kahn played a major role in the conceptual formulation of open architecture networking, which would allow computers and networks all over the world to communicate with each other, regardless of the hardware and software each were using. Over the past 2 decades, he has devoted his creative energies to reconceptualizing the Internet around the notion of managing information. The result of that effort he calls digital object architecture. Of which are now are in widespread use around the world. This architecture solves some of the most critical infrastructure issues involving interoperability of different information systems with concerns for integrated security, persistence, and privacy. He is currently applying these architectural ideas to a number of important pilot projects, including healthcare and the so-called Internet of Things. Earlier this year, he played a role in establishing the Donor Foundation as a nonprofit, multi-stakeholder organization in Geneva to oversee the management of key components of the architecture, namely its distributed identifier resolution system. Ladies and gentlemen, as you can imagine, the amount of awards that this individual has, it's too long to read. Without further ado, ladies and gentlemen, the co-father of the Internet, Bob Kahn.
Ladies and gentlemen, I am delighted to be with you here in Guadalajara. My first visit to this lovely city, and looking forward to sharing some thoughts with you today. When Jim Poissant asked me to give this talk here, he gave me just a couple of pointers. One, he said, don't make it too technical. Number 2, he said, give a personal view of what happened in the past. And I said, well, I really would like to talk about the future and where things are going. So what this talk today will be about is a little of the past, some of the present, and roughly speaking, what I see as a future, roughly for the digital object architecture, but also some highlights of some other things. But before I get started, let me just mention one thing. Fadi Shahadi, in his talk this morning, talked a little bit about internet governance. The reason that that topic has been with us is that there is such global interest in the internet, and it's been going on for quite a while. Really, instead of being about internet governance, since he made it very clear that there's no one place to govern, it's really more about global coordination of internet-related public policy issues. But that's too big a mouthful for what some people would like that to be about. But when you think about it, it all derives from the one question he posed that really came from other people as well, namely, who runs the internet? Who's in charge? And I got to think about that. It's not an unreasonable question that people have asked, but I often wondered why they ask it about the internet when they don't ask it about other really important systems that affect the whole world. Okay? Who's in charge of the world economy? Think about it. Why doesn't anybody ever ask that question? Who's in charge of the weather? Affects everybody. Why doesn't anybody ask? Well, I guess we know who does the weather. That's Mother Nature. But in principle, I'm really hoping that the question of who's in charge of the internet sort of becomes the same kind of non-question as we deal with in some of these other areas, because it's really a distributed, global, coordinated kind of activity. And as soon as people really internalize that, they'll realize they can control the parts of the system that they can control, and they need to coordinate and collaborate with everybody else on all the other issues. And that's going to involve governments, it's going to involve the private sector, it's going to involve collaboration among all the relevant stakeholders in this process. So let me begin, and I guess this will, let's see if that works. Okay. So this is a little about the past. How did the internet get started? Well, it was really about interoperability of computers and networks. We had 3 networks to begin with. I was involved in all 3 of them, 2 in an architecture and design capacity, and the other one in a project management capacity. I'll give you a little glimpse of that. This was all driven back in the 60s and early 70s by US government funding, and it was implemented primarily through the media of university research sites. All of this networking technology really started out as international from the very beginning. On the ARPANET side, we had links to Europe, and when the packet satellite came about, the very first implementations of the TCP/IP protocols involved University College London, Ulbranic and Newman, and Stanford University. I gave a lecture at the National Academy in Washington probably almost 15, 20 years ago, and it was one of these Intel or Westinghouse science searches. I forget exactly the title of it at the time, but there were about 1,000 finalists, and this young lady who was about 15 years old was the spokesperson for the group, and she said, after I talked a little bit about the internet, she said, "We thank you for what you've done, you and your colleagues, but we have one question we're dying to know the answer to." And I said, "What's that?" And she said, "How did you manage to convince all the governments of the world to let you build the internet?" Well, I thought that was a very insightful question. It's what you might expect from a youngster who really doesn't know how to deal with the global environment yet. And I said to her and everyone else in the room, "I'll be happy to answer that, but you're not going to like the answer." And I said, the reason is we didn't have to convince any of the governments because nobody at that time thought this was a very good idea. So they gave us free running room pretty much to do what we want. And it was only much later that they realized that there was some important aspects of this that they better take a closer look at, and they really did. So I want to give you a view of what some of these early networks looked like. The packet satellite net, at the time we did that, there were no domestic satellites, so the only thing we had to work with was Intelsat 4, which was this international system that involved very large ground stations. Here's a picture of the ground stations that were on the US side. We had similar ones in Europe, and this was a way to link the United States and Europe using satellites, but in a packet switched mode. Now, the other thing that we did was we created a mobile version of the ARPANET. That was involved packet radios. They were about the size of a bread box, weighed about 70 pounds, so you could lug them, but you couldn't put them in your shirt pocket. They're about a cubic foot in size. And here was a picture of the van that we used. Inside the van, we had all the packet radio stuff, and we would drive up and down the Bayshore Freeway in San Francisco, running tests. And in fact, the first 3 network tests that involved the ARPANET, the packet radio net, and the satellite net occurred in November of 1977, and it was memorialized by an event at the Computer History Museum in 2007. Just to put a little personal note on it, I could have shown you multiple things about the ARPANET, but I chose to show this one. This is a picture of the set of us who were involved in building the ARPANET. I don't know if this is, you see this? That's me. As a youngster, I was probably late 20s or early 30s at the time, and this thing in the back here was the packet switch for the ARPANET. It's like a refrigerator-sized Honeywell computer that was ruggedized so we wouldn't break if we dropped it, and that's what made up the ARPANET. So we had these 3 different networks, and the early days of networking was about figuring out how to make them happen. People have written a lot about packet switching, how it works, each of these networks, the protocols, the details. I'm not going to go through that again here, but one of the things I do want to emphasize is that the reason this was all successful, and in particular the internet, was not because of the technology, even though it is notable that the TCP/IP protocols have now worked over a scope of technology increase of over 1 million from the time we started in the early 1970s on the internet protocols until today, and it has no signs of not continuing, so it might very well scale to 1 billion. Think of any other technology in history that has continued to work over that large a scope of technology change. So the reason it did is because we abstracted it from a lot of the underlying technologies. So the internet was not about the underlying technology, it was about whatever that underlying technology was, how to make it work together. So the most important aspect, I think, of its evolution and taking hold were the social structures that were created. Many of you have heard about them. I'm not going to describe them in detail, but here is, let's see, I guess I gotta do it like that. Here is a list of some of them. It started out with something called the Internet Configuration Control Board that Vin Cerf and I set up back in the late 70s to help people who wanted to get on the nascent internet at that time figure out how to control their computers to be able to do that. By about 1983, Vint had left and Barry Leiner took over running that. I trained him. Barry was more interested in managing a process that was outside of DARPA than inside of it. So he and Dave Clark from MIT set up something called the Internet Activities Board that later morphed into the Internet Architecture Board. This was a group of about 10 people who basically took the responsibility for helping to evolve the internet with guidance from DARPA, but not directly controlled by DARPA. Under that, there were initially some 10 working groups on things like routing, autonomous systems, security, but because we were trying to get the internet up and running, it was like when you buy a new house, there were things that need to be fixed, like the door is stuck and the faucet drips and so forth. So you create a list of things that need to be remedied to make it work well. We call that the punch list. And so we had one group, it was called Internet Engineering, that managed the punch list. But by about 1985 or so, the internet was now up and working and all of these details were pretty much taken care of. The working groups had expanded from about 10 to about 50 by that time, and so the task was given by the IAB to this Internet Engineering working group to become a task force to manage everything else. So that became essentially the de facto standards body for the internet in due course. In the early 1990s, we actually set up something called the Internet Society. I signed the incorporation papers. along with people from RARE in Europe and Educom in the US. Internet Society is now playing a major role in explaining the technology, promoting it, and they provide a lot of very important services for the community at large. The Internet Corporation for Assigned Names and Numbers, ICANN, that Fadi Chahadi runs, was formed. ISI had been running that service. In fact, the fellow who did it there, John Postel, I handpicked to do that back in the 1970s. I had been running that function myself for about 4 years before that on an index card in my pocket. And so John took it over. They set up an activity there, and it became so complicated in the mid-1990s that it was spun out, and ICANN became the body that took that responsibility under an agreement with the U.S. government, as you heard this morning. In the early 2000s, because of growing interest around the world, there were several world summits that were held under the auspices of the United Nations. There was WCIT in 2003 in Geneva. There was phase 2 of the WCIT because they didn't solve all the problems of governance in the first one. No surprise there. They held a second one in Tunis in 2005, and they're now contemplating perhaps another one next year. So that played a big role in getting the world community together. And of course, the Internet Governance Forum came out of that activity, and they've now been through, close to 10, I don't know the exact number, maybe it is exactly 10, where people come together to talk about Internet governance. Personally, I would rather see a much more benign name for that, but I think the reason people feel like they need to be at those meetings is because with a title like Internet Governance, they're afraid something might actually happen that would affect governance. And so it's a real calling card in some ways. But it's an important event for people to share ideas, discuss issues, much like this is in a somewhat different context. So I just wanted to point out the importance of that. Now, there are some other areas where I think it's really important that we have a really good understanding. One of them is sort of, what is the Internet? Almost everybody has an idea of what it is, but if you ask somebody to really define it in detail, they will probably have trouble. My personal definition is one that was adopted some 20 years ago with help from people in the community, that the Internet really is a global information system. It's a system that facilitates the flow of information from one place to another. It's not about the underlying networks, it's not about the computers, it's about the protocols and procedures that let things move, back and forth. And Internet governance really has so many players that are currently involved today. It's really hard to see how that can be sustained as a subject area. It's going to have to focus on more specific things, I think, going forward. And finally, what about all of the other things you hear about? To me, they're all part of the Internet, the Internet of Things. It's all about managing information about the things, which is what the Internet is, I think, emerging to, as you've seen with the World Wide Web. Cloud computing. These are distributed services on the Internet, part of the Internet. Software-defined networks, network functional virtualization. These are all things that people are working on, and some people think they're different from the Internet or brand new. To me, it's all the same thing. They all rely on IP addresses or functional, logical follow-ons of one sort or another. And then there are all the other things that are coming along, like the work on big data. There's a big effort on research data that the US, the Europeans, and I think Australia got together to set up, but they have this Research Data Alliance that's focusing on sharing research data. People are developing sensor nets all over the place. They're largely intended to be Internet compatible. So these are all going to be part of the Internet in terms of the information flows. Same thing is true of efforts to ship around TV over IP and claim it's different from the Internet. Well, if it's using IP, I would argue it's the Internet, just happens to maybe be disconnected. The VoIP, which is a packetized way of sending voice, is essentially more the same. It's using IP to deliver voice from one place to another. So a few myths I wanted to sort of debunk here. One, people often say, well, you didn't do wireless originally, it came on later with the cell phone revolution, and the answer is, actually, wireless was there right from the beginning. Of the 3 initial nets that we connected, 2 were wireless. satellite net and the packet radio net. The second myth is that end-to-end is a basic principle of the internet. Now, it's important in many cases, like the World Wide Web is a client-server model, and so for that model, you don't want the intervening networks to do anything to interfere. But there are many other applications that you can think of, including conferencing applications, distributed simulations, and the like, where the intervening networks may be able to play useful and functional roles. So end-to-end is an important thing for some applications. It's not desirable, in fact, in some other applications, but it's not an integral part of the internet as we originally defined it. Now, I would say IP addresses are absolutely an integral part of the internet. It doesn't work today without them. But the domain name system is an application that maps names into IP addresses. It's embedded in so many parts of it that it's hard to see how you could do without it today. But it's not an intrinsic part of the original internet. It was something we added later. In fact, I made that selection in 1983, and we put it in shortly thereafter. And finally, people often say, well, the problem was you didn't think about security early on. And that's the one that bothers me the most, because that was one of the things that we were most interested in providing. But it turns out that even though we pushed it very hard in the early 70s, we never got closure on it because of the inherent conflict between the need of the private sector for security in their undergoings and the need for government's interests in dealing with both law enforcement and national security. So until those two competing tensions can be resolved country by country and maybe even globally, you won't have security at the level that many people thought we could have had early on. Okay, so about the future, I'm going to tell you some things that I'm pretty sure are true. I'm not going to spend much time on them, and then I'll get into the digital object side of the world. So clearly we're going to see more network capacity. I mean, that's just almost a given. We're going to see higher user access speeds. Not everybody has gigabit access speeds today, but maybe they will in the future. People still, some of them use dial-up, but you're going to see an increasing push toward low-cost, affordable, high-speed access to users or their premises. I think we're going to see many, many more wireless devices and other things that use wireless to connect them, maybe even things that use landlines to connect or just direct internal wiring. We will see better security, but it's not the kind of security that's going to be absolutely foolproof. In fact, even if somebody thought they had such a system today, you know, if the computing world goes the way I imagine it will, they're going to have to reinvent how to do better and better security every few decades as time goes on. Who knows what quantum computing will do to cracking codes that are considered uncrackable today. I think we'll see apps of all kinds, most of them unimaginable today. And if you think about it, if the World Wide Web had come much later than it did and wasn't so built into everything, the browser today would just be an app that you download from one of your favorite app stores. But we'll see much more of that in the future, and I think there's going to be a big focus on information management and access. The World Wide Web is really the first out of the gate. It's widely used, it's very effective. I use it all the time myself, but it's not the last word. It's merely what's here today. We're going to see much better schemes in the future. And most importantly, I think we're going to have to come to grips with the issues of interoperability of different information systems. Because if we don't, you know, for those of you who understand how difficult it was to move from a small parameter change of moving from IPv4 to v6, if you try and, say, take something as complex as distributed medical informatics information systems and try and change the interfaces to all of that in the future, in every country of the world simultaneously, an impossibility won't happen. So we're going to need to understand that, and the digital object architecture has the potential for dealing with these kind of problems. So let me spend the last few minutes I have in my talk and talk about that. So what I think we're doing is we're moving from a focus only on packets and routers and IP addresses, which accommodated the movement of bits from one place to another through this global information system, to a higher level representation in terms of digital objects. I'll tell you what they are in a moment. Identifiers for those digital objects, unique identifiers, I mean. Metadata that provides information about those objects to help you find them, and a protocol that lets you actually talk to a digital object directly. And the nature of that protocol is one that depends only on identifiers. So no matter what the technology is like in the future, you should still be able to access those protocols or parts of the object that the protocols connect to. These identifiers are only useful if they properly resolve, and so identifier resolution systems are going to be critical, and what we're trying to pursue is interoperability between these different identifier resolution systems. So what are the issues we have to deal with? Persistence, so that information can be accessed now and in the future without having to worry about a machine disappearing or a company going out of business and the like. Authentication, so what you get, you know what it is. Identity management, my vision of the future, people can still be anonymous, but their identity will be anonymous, and they may have less ability to access certain things as an anonymous person than they will with a real identity. How those identities are managed, who will be the parties in charge, how we trust those identities, and so forth, is still an open issue in many quarters, but I think it's going to be one of the important ones going forward. And finally, security and interoperability are kind of right up there at the top of the agenda, because if you don't have security in the system, you don't know who to release certain information to, and if you don't have interoperability, you may not be able to get it from the system that you're currently dealing with if the information is somewhere else. Now, one of the important developments in the last year or so was the agreement at the ITU on a framework for interoperability. It came in the context of identity management, but if you read that particular recommendation, you'll see that it really talks about interoperability of all kinds of information, and I commend that to you. You can find it on the net. Just Google, I guess, ITU, and the name of the recommendation is X.1255 as listed over here. So that was approved. It was improved on the most stringent approval process by all the countries in the world. So I think it's going to be an important contribution. So in terms of application areas of this particular technology, it's widely used today in the publishing industry, mainly for managing their assets, and in particular for managing citations in published materials, digital published materials, or digital materials on the internet, if you will. So if you put a digital piece of material on a digital bookshelf, you'd like to be able to take that off just like you would in a regular library at any time in the future and still have the citations in the back work. Well, if you rely on URLs, you know, the half-life of them is measured in years, or not much longer than that in general, and you want these to last in perpetuity. So that's one of the reasons the publishing industry went that route. The entertainment industry in the United States, and I guess in some other parts of the world, are now using this identifier thing to deal with their movie assets and similar things. And we also created a registry for them to be able to manage the business rules that apply to all of that. Government information, I think, around the world could make use of this technology. Governments in particular have a number of real requirements to maintain things over very long periods, especially national archives, but for most government information. It'd be very useful if it was a simple way to get to that information in a secure way in the context of which you want to find it. And finally, many products on the market today are resolvable through these identifiers to give you state information about the products. And it's coming up, I'm going to be giving a keynote at a conference on counterfeiting, where this technology we expect to play a key role in helping people to understand what's legitimate versus what's not legitimate. Some potential new examples, The sharing of research information in particular large data sets is something people don't really know how to do well today. They don't know how to discover them, they don't know what's in them, they get the data, they don't know how to interpret it, and there is no ecosystem in place for allowing that. That's what the Research Data Alliance is trying to figure out, and I think this architecture will play a key role in that. Another area is the healthcare system. I think the real value of this in the healthcare system is not just that it provides affordable solutions, but it affords solutions that are persistent, so these health records can last at least over the lifetime of the patient, perhaps longer, that the different systems, and there surely will be different systems, every country will have its own approach. If they're based on identifiers and you can access the records through the identifiers and the security that's intrinsic to the system, and we have a fighting shot at interoperability. Furthermore, we can augment the protocols and the interfaces by just creating more digital objects, because they're identified as well, and they can be executable programs and the like. In the smart cities world, people are looking at the potential use of this because they would like plans to stay around in perpetuity, or at least, let's say it's a plan for a building and you want to put an addition, you want to know what the original plan was, where the embedded capabilities and facilities are in that building, what the codes were when it was built, what's changed. And this needs to be persistent and needs to be secure. You need to be able to bank on it. And finally, and these are just examples, distributed simulations, which I think are going to become more and more interesting over time, where people in different places build parts of a simulation based on an architecture that allows those pieces to interoperate, and the linkages, the linchpins, will be these identifiers. So those are just some examples. So what is it about the architecture? Well, first of all, as Fadi said, within the internet, where we're dealing with the movement of information, identifiers are really key there. They're very key in managing information as well. I believe that we'll be talking about digital entities of all kinds in the future internet. Every digital entity has an associated ID. It's not a digital entity if it doesn't have an ID. So it can identify people, systems, information, and any defined resources that you want, including anonymous. The reliable resolution of these IDs to state information is what's key. So what do you want back from state information? You'd like to know, where can I find this information? Maybe 10 IP addresses that might work. You'd like to know, what can I do with the information? You'd like to know, how can I authenticate it? You might like to know, what are the terms and conditions that apply in certain contexts. You can build that in yourself. Nobody's going to tell you what to put in, but anybody now who accesses that information can understand what it is about that information that the creator of it intended. The fact that the protocols deal primarily with IP means they can deal with any network of the future by just allowing connections with whatever the protocols of the future are. But if it's IDs that count, you're looking for something, you don't have to worry about what storage system they're using, you don't have to worry about how things are otherwise packaged, you don't have to navigate anything. The protocols will manage to get it back to you. You may have to prove who you are and that you have the rights to access it, but that's where I think that's going. Now, a repository is a term that people are pretty comfortable with, but if you think of a digital entity or a digital object as being able to store other digital objects inside, then a repository is really nothing more than a digital object that's got other digital objects inside of it. And so the repositories can have their own identifiers and like. In fact, these repositories can be mobile. They can come to you as opposed to you going to them. So it's a really powerful idea. Interoperability is key. But if they implement a digital object access protocol, they'll all be interoperable by definition. Just like, if everybody uses a TCP/IP protocol, they can talk to anybody else who uses a TCP/IP protocol. So that's really important. Now, the registries keep metadata records about these things. So that's what allows you to find them. You're not going to remember an identifier for an object that was created 100 years ago, but you may know something about it that the registry will help you find. Now, the simplest thing to do is keywords, but as the research community continues to improve in this area, you're going to find more and more ways to do smart searches. You can search by cartoons, you can search by pictures, you can search by more natural language inquiries, and this is a really fertile area in the research community. These registries will all adapt to what that technology is. As these go on, we're going to see more integration, because anybody who runs a repository wants to know what's inside of it, and anybody who runs a registry needs a repository to store their metadata records. So increasingly we're seeing registries and repositories become sort of the same thing, and the only question is what purview are you using it for? Are you using it to keep track of only your own materials, or are you using it to catalog what's out there in the more global world? And I think we'll see both the. And so within this whole system, what it really does is allow distributed management of all of these records, and the most interesting part of that from my perspective is how you maintain the integrity of the system going forward, how we avoid the same kind of traps that we had in dealing with internet governance going forward with ICANN. So let me just briefly talk about that, and then I'll be finished with the talk. So today there are many different identifier resolution systems. I'm going to focus my remarks here on the one that's part of this architecture. We call it the handle system. The handle is just simply the way you get to a particular digital object. We developed it. It's been on the internet now for over 20 years. We do all the administration. So when somebody wants to run a local handle service, they come to us. We don't charge to download the software, but we do run this global handle registry, which allows any user to know where the local handle service is. And there are presently probably somewhere between 5,000 and 10,000 local handle services around the country. Some of the biggest ones are actually more concentrated, but there are lots of them, and it's all over the globe. Well, right now there's a single administrator of this system. It's my organization, and we have had discussions over the last probably 10 years with different parties around the globe. It really would be nice if we had a more distributed way to deal with it, because what happens if something happens to my organization? Who steps in? Maybe we won't be comfortable with them. And this started out with a discussion with the Max Planck Institute folks on behalf of the big data initiatives in Europe. But then we got other governments weighing in who are less comfortable putting government information into a system that a US organization was dealing with. And so we had a number of different alternatives that were put on the table as to how to deal with it. Some parties wanted the ITU to take it over. Some parties said anybody but the ITU. We had concerns about where this system would be housed, if anywhere. One of the suggestions was don't make anybody in charge of it. But the questions that came up then was, if you have multiple administrators, who gets to pick the next administrator? If you're building security into it, who has all the keys and does all the signing? And furthermore, if you have an organization that can do that, what happens if that organization goes out of business? So we had to deal with all of this. And the conclusion was to set up a foundation in Geneva that deals with digital object numbering authority. That's what it does. It really maintains the keys, and it maintains the overall administration support to this particular thing. It'll have a process by which more administrators are brought in. Initially, we have 4. We're going to have probably 8 by the end of next year, 12 by the end of the year after that. Eventually, I don't know, we might have something as broad as every country in the world could have it, or every major business sector could have something like that. We'll have to see how that plays out. But it's going to be multi-stakeholder, and it was set up earlier this year in Geneva. Everything that's being done with this architecture is totally compatible with the internet as we now know it. We've actually done interoperability experiments with the DNS, so we know that part of it really works well. The current 4 administrators that have been designated here are ourselves, since we've been doing it, and we have all these multi-year contracts with everybody, so we couldn't not continue to do what we've been doing, but we've empowered some others. One is an organization called GWDG. I don't have the exact German translation, Gesellschaft für Wissenschaftlich or data something, in Germany. It's part of the Max Planck complex, but they're doing it on behalf of the European dataset community, and maybe even broader than Europe. The ITU, on behalf of the United Nations, they're not going to go beyond that. And then a group in China that has called itself the Coalition for Handle Services in China, which is a grouping of government body out of the MIIT and some private sector companies that are all working in concert. So the main responsibility of this foundation is oversight of this global registry. That's all it's going to do, plus pushing for outreach on pilot projects in places that find the technology of interest. So I know some of the developing countries will be high on the list, but there may be others as well. And the whole intent will be to demonstrate the power of the technology and foster interoperability experiments. For those of you who are interested in this whole area, we are currently building a website. It's pretty skeletal at the moment, but it's got some of the structural parts of it. Donna.net, you can see it listed here at the bottom over here. You won't find much there, but within the next 6 months or so, it should be a much more embellished site. And so let me just conclude with some of the important things I'd like you to take away from this. One, I think there are significant changes in the internet having to do with the management of information. So this is going to be an important topic. I think it could be more important than anything that's happened yet, because information is the lifeblood of the system. That's why people tend to use it, to send email, to access information of one sort, to communicate with people, to manage their historical information. The social aspects of managing change have been, as I pointed, and will be essential elements for the evolution of this technology, and indeed for any technology that's in widespread use and needs to evolve. Digital objects, or what I would say more generally, digital entities of all kinds, will become the lingua franca. I mean, right now we talk about packets, but nobody ever says, I want the packet that I sent 4 years ago from. They talk about it at a higher level. That's where I think we will merge to. As I said before, identifiers are the linchpin. Stable management of these identifiers will be critical. We don't want the identifier system broken in any simple way. And interoperability will be essential because we'll probably have multiple systems, at least initially. They need to work together. And I believe that as this kind of capability gets out more and more, we're going to see all kinds of new applications. Some of you in this audience may be involved in developing them, for all I know. But I think these capabilities will let us do amazing things in terms of archiving, more security, access to global spans of information over many, many years. And I think it's an important contribution that you just needed to be aware of. So I thank you for the opportunity to give you some of my perspectives on the internet and how it's evolved. It's still evolving. I think it has the potential to keep evolving for as long as people have good ideas. And I hope you all become part of that process going forward. So thank you very much. Sorry, I went over a few minutes.
Thank you. No, you're good. Bob, we're going to give you a little bit of a gift, but in the meantime, I'd like to share with the audience something that's kind of special. In addition to what Bob has done in his life with his achievements, this man has flown over 9 time zones to be here in Mexico with us, and we want to thank you so much for that. Thank you so much. Please.
Is it heavy? No, good.
Okay.
Thank you.
Come over here for just a quick. Okay. Okay. All right.